This video is about various topics in the STOE model of everything, which may lead to future papers.
There are summaries for the scalar theory of everything, just to brief you on what we're talking about here. This is a paper, and this is where you find the paper, and there's a YouTube explanation here about generally what's happening. The Musings YouTube video is about problems that I've seen so far in the scalar theory of everything. And of course, I have lots of other videos here. I'd be interested in any experiment or observation that would reject the scalar theory of everything. The topics I'm going to talk about or thinking about for future papers is the plenum real? Second topic has to do with the gradient of the magnetic field being gravity. Next, we'll talk about the fine structure constant in the STOE model, friction in the STOE model, the wave equation versus the heat equation. This is a very general, subtle topic. Then entropy, and then the structure of particles has to do with how they get their properties. The first topic, the plenum in the scalar theory of everything is considered to be a real component of our universe along with hods. The concept of ontological interpretation of physics implies severe restrictions for evolution-type laws. Thus, numerous paradoxes, measurement problems, anomalous observations, etc., must become intuitive through causation. The STOE suggests hods, or matter, plenum, and their interaction are real and emerge to everything in the universe. Reality means what we observe in our classical universe. A real continuous plenum, or an aether, solves the decoherence measurement problem in quantum mechanics. It includes a superluminal transport of force, otherwise known as spooky action at distance, and it solves Bell's inequality issue. Thus, the universe is fractal. Our size scale model, the larger and smaller size scales. The universe must be intuitive to our way of thinking, and it must be causative, because that is how we view our size or classical scale. The plenum is real. That is an issue primarily in quantum mechanics, where waves may be real or merely probability calculations. The STOE suggests a causation model using a continuous plenum medium to cause forces on matter and hods and the hods in turn cause plenum change. The walking drop experiments appear to be hydrodynamic analogs of quantum mechanics at the macro level. The de Broglie pilot wave hypothesis suggests the waves and their medium are ontologically real, independent of an observer. These waves are called empty waves, meaning real waves without matter, or de Broglie waves. Matter being corpuscles, not de Broglie's other quantum wave packets. The distinction is that our detectors measure the matter, the STOE hods, and not the empty waves. The popular Copenhagen interpretation of quantum mechanics suggests the waves are merely probability mathematical waves and are not real. De Broglie, Bohm, and now me in the STOE suggest the waves are in a real medium. However, the STOE has the additional suggestion that the hod is also discrete, that is, not a high-energy kernel of a wave, which is a singularity usually detected in quantum experiments. The diffraction effect in the Copenhagen interpretations suggests light is a wave or a particle. The STOE suggests light is a wave in the plenum and a particle of hods. This paper, the proposed experiments to clarify the real nature of the quantum wave, proposed several experiments to support the reality of the empty wave using Copenhagen interpretation math. The perceived problem is to have an experiment that is not explainable in the Copenhagen interpretation. They use several photons that may be treated as biphotons, that is to say, entangled such that they are calculated as one-way function. The other effect is the HOM effect, demonstrated in an experiment by Alan Aspect, where photons appear coherent when emitted by a beam splitter. The STOE suggests the photons in a laser beam are coherent in the sense of this effect. But this effect is discounted when the optical path lengths differ and a beam splitter is not used. And therefore, these experiments must make sure that the beam lengths are equal. As you can see, the possibility exists to have different beam lengths after the beam splitter. And you will notice here there's a single slit and two slits, and then they're looking for the counts. This is another experiment done where the beam is split and then is directed through two kinds of slits. One of the slits is short, the other one long, where what the author is claiming is that the laser light going through these two slits produce that kind of a problem, which is an interference pattern, and you can see the fringes, and the beam going through this slit through the bottom path without another hole over here is producing the diffraction pattern. You'll note that these are not photographs. What I intend to do is to look at this experiment, which has been published here, and there are YouTube videos of doing this experiment. What we're going to do is do this experiment backwards to show that the plenum is real. That is, the plenum wave or empty wave of a photon, coherent light in a laser, is detected without additional photons by the difference between a diffracted and an interference of light on a screen pattern. Modeling a photon laser light may not have a Mandel dip, which is necessary in the previous context. Because the STOE has only one optical path length for each photon, whether laser light is a series of single coherent photons or not, in low-intensity experiments or a group of photons, as Mandel dip suggests, is irrelevant here. Neither is modeling a quantum particle or biparticle necessary. All that is needed is that the laser light through the slits produce a diffraction pattern and an interference pattern. I think this experiment also rejects Copenhagen. This is the experiment in reverse. We start with the end experiment, which is a laser light through a single slit mask, which produces a diffraction pattern. Then it passes a nail, which has the goal of blocking the central maxima, and then a glass plane on a screen. Now, there's a trick here. The nail is used because it's straight sides and smooth sides, so there's no little fibers hanging into the light path. If you place the nail in the center of the diffraction pattern here, where there's light on both sides from the central peak, then you will get this kind of an image on the screen. There's the diffraction peaks, and behind the nail, you see there is some light. This is standard physics. This has been known for a long time. However, if you place the nail such that the edge of the nail is beyond the first minimum, a little bit beyond, or in the first minimum, on either side, on both sides, what you get is nothing in the middle. And there is going to be a slight shadow here, as you see here with the nail. Okay, the second step in the experiment is to take that glass plate and make two glass plates with a separation of about 0.5 millimeter. This then becomes a slit for all practical purposes, and what you'll see on the screen will be an interference pattern, and that's what we're going to look at. So this is the experiment forward, where there's the image from the first mask, which is a diffraction pattern, very nice. This is the diffraction pattern with the slit in the glass plate. And you see you do have an interference pattern because these diffraction peaks are turning into fringes. The last step here is to place the nail to block out the central peak, meaning this central area, in which you still see the interference fringes without any light going through the slit. So here you go. Without the slit, you see the diffraction peaks with no fringes and no light going through the center area. Here you see the interference fringes with the diffraction peaks and no light going through where the nail is. So here's the plenum model. You have a photon between the mask and the screen. The photon emits a wave in the plenum, which travels back superluminally, reflects off the atoms, and does not reflect in the slit. These reflected waves join and then direct the photon to the screen in the interference fringe pattern. You'll note that there's only one photon at a time in the experiment, and yet the presence of the mask without any photons going through it are affecting the photon. That is, the photon is following a path caused by a wave from itself and from a slit not in its path. Both photon and slit characteristics are represented in the equation of interference, which is the typical Fraunhofer equation. The plenum is real. Another possibility is that the photons or waves on each side of the nail are coherent. That is the biphoton concept. Alan Aspect showed entanglement over several meters, so this is not out of the question. But biphoton concept is rejected in this experiment because the without slit image should then also show interference, and it doesn't. The STOE is a holistic emergent model. This experiment demonstrates an effect that must travel from the photon, which encodes photon characteristics, to the slit, which encodes slit characteristics, and back to direct the photon. Quantum locality says this experiment effect is not possible. Therefore, quantum locality is questionable. The second topic is that the gradient of the magnetic field in Gauss's law and Maxwell's equations is equal to zero. That is to say, there are no magnetic monopoles, and if you integrate over the surface, you end up with no net outward flow. What the STOE suggests is that what comes out from that surface is essentially gravity, that is to say, an attractive force to these hods, which are north and south poles of a magnet. These experiments, which I've done, and you can look up here, suggest that Maxwell's equations are slightly wrong and suggest that there are two different types of magnetic field, electromagnetic field, and a permanent magnet field. Part 5 of a series of 5 papers looking at the repulsion force between north and north poles and south poles has a slight asymmetry. As noted here, this is the summary of it. That asymmetry is gravity. So, following flux lines, this side of my hod, here represented as a horizontal line, represents the flux lines, but weak, that is to say, a small number of flux lines compared to the stronger side, which requires additional flux lines, which cannot come from the other side of the magnet. And therefore, these flux lines are then attractive, which turns out in the plenum to be gravity. The STOE model is that plenum is a magnetic field. The magnetic field is the only force field that's present. Electric effects are vortices in the plenum, and there's the paper where you can see it. This also suggests that the weak and strong nuclear forces are ad hoc additions to account for the supposed electrical repulsion of nucleons. If the nucleons are magnetic, they don't need to have some kind of repulsion effect. That is, the weak and strong nuclear forces don't exist. So here's how it works. If you have a distribution of hods, these each are going to have some effect on a surface area around the hods. You'll note that very close into the hods, that attractive force need not be necessarily spherical. But the STOE suggests the plenum obeys the heat equation, which means the plenum density flows from higher to lower points, but is never less than zero, even perpendicular, such as right here, to the radial direction. After a while or some distance from the hods, the vector perpendicular to the direction of the radius from the center of mass goes to zero, because that's what the heat equation tells it to do, and therefore you end up with a equal potential surface, which is spherical. This then is the spherical principle. It comes from the heat equation. There's no rebound that inertia would cause as in a wave, but the heat equation is necessary to have the spherical principle, which yields e to a real exponent, or the 1 over r factors. The moving hods produce first a decline, then move so that the plenum density at distant points appears to decline, then rise as hods pass and rotate. The distinction is also found in standard physics. The point-particle concept is so the spherical principle, then the heat equation, may apply rather than the dipole, quadrupole, or Fourier equation needed. So point particles, which are quite possible, derive from a need to have the spherical principle. But the heat equation can be described by the Fourier series. The universal equation that I use uses only the first cosine term. With the gradient of the magnetic field being gravity and the previously mentioned experiments that I've done, the Maxwell's equation should be redone. The new version should reflect magnetic dominance, two different magnetic fields, and should include gravity. So, if the gradient of the magnetic field in the plenum is equal to the number of hods in the spherical surface radius at a sufficient radius for a spherical surface approximation, and hods produce gravity, the number of hods determine the gravitational potential. This is why the Newtonian spherical principle applies to gravity, and of course all those other places where point particles are theorized. This is the link between Maxwell's equations and Newtonian force equation. It applies to distances which are greater than the atomic radius. That is to say, for instance, it suggests the Casimir force is magnetic. So inverse square law force is questioned for subatomic particles. Alpha, the fine structure constant, was detected by a slight separation of spectral lines thought to be because of electrons with different spins in an atomic shell. The Bohr model of orbits and relativity, which included a pure number alpha, and alpha here was calculated like this, based on the idea of electron orbits and momentum and energy in electron orbits. The alpha, the fine structure constant, is found in many different experiments. The spectra of atoms is the energy of emitted or absorbed light. Accepted physics hold that light is a wave, so the energy is Planck's constant times the wave frequency, and has a speed c as a constant. Spectra being discrete lines suggests the spectral light waves are discrete. The Bohr atom combined with quantized energy yielded the Rydberg constant, which agreed in form with the formula found by Balmer in his Balmer series. But the STOE rejects a constant c, because c depends upon the plenum density. It rejects the Bohr model because electrons don't orbit. And the reason they don't orbit is because there's no emitted radiation, so the Bohr model is falsified. It rejects light as a wave. Light is fundamentally a particle. And it rejects Planck's law that energy is proportional to the frequency and the de Broglie wave-particle equivalence, as we talked about earlier, but accepts that the Planck constant from the photoelectric experiment is the discrete unit of energy of the hods. The fine structure constant, describing the spectra as an orbital angular momentum characteristic of electrons, became untenable because radiation should be emitted. Later attempts became weirder and more complex using quantum mechanics. The fine structure constant, the speed of light, is dependent on the plenum characteristics of magnetic permeability and electric constant. Planck's constant is a relation of energy to frequency, traditionally, which the STOE relates to the number of hods in a body needed to form light interference. And here's a paper to look at that. Electric charge measured in coulombs, the numerator of alpha, in the DeSangro experiment and others measured the speed of the Coulomb field to be much greater than the speed of light, and there's the reference for it. Speeds of light or less are of real bodies in the STOE because the body is made of hods. Speeds much greater than the speed of light in the STOE implies the thing is of a plenum. The Coulomb field, therefore, is a plenum field. Here then is a model of electrons and photons using disk magnets to represent hods. So here we show the net north poles. South poles are opposite that, of course. Top corner, bottom corner for the South Pole. And this then would be the direction of motion as the electron travels through a plenum. In the photon, there's the direction of motion, and of course there's one north-south axis. The same for the arrows indicate the orientation of the relative direction of movement. Constant implies no spin, no spallation perpendicular to the current. This is the electron traveling through an inhomogeneous field, which is a Stern-Gerlach experiment. And you can see the electron rotates about one axis is the North Pole and then about another axis, which gives its half spin or 720-degree rotation. Therefore, the spin measure is a result of magnetic poles and the direction of movement, not to the rotational motion, because the electron is held by its motion. In the structure of the electron in an orbit, what you have is here's two electrons, and there's a connection to the nucleus by a photon, which is a column of hods. And you'll note that when you do this, there's a natural angle that comes here. But the STOE doesn't have orbits or spins. The fine structure constant, the magnetic permeability, and the electric constants are characteristics of the plenum. The magnetic permeability is inversely proportional to viscosity, or its inverse is viscosity. So in analogy to waves in a medium, we have the speed of light squared is inversely proportional to the permeability divided by the electric constant. And so all of these constants vary with plenum density. Matter is the emergence of hods and the plenum, wherein the hods capture and hold the amount of plenum between hods. The plenum density environment controls the spacing of the hods. Closer to sources has less spacing. So alpha is the amount of plenum captured by a single hod. You note the various constants in the electric and the constants are all related to the plenum, whereas the Planck's constant is related to the hod. So alpha is the amount of plenum captured by a single hod. It shows in equations that want to relate the number of hods to plenum forces. So this is the reason for finding alpha in so many places. Whether alpha varied has been studied with no change verified, but according to the STOE, the studies look in the wrong places: distant quasars, local nuclear plants, etc. The STOE postulates all constants change and are dependent on the plenum density. According to very high rho near the sources and at the center of spiral galaxies, we expect to see the alpha change, or in very low rho between galaxy clusters, we expect to see galaxy change, and therefore there should be no carbon very close to the sources, and further out there should be no atoms. Is the alpha dimensionless? It depends on what charge and Coulomb mean in the plenum, and the units of the plenum, which are so far defined. Certainly, the count of hods is a unit of measure that is not usually considered in dimensional analysis. So we need a few more measures or standards, such as the count of hods and whatever plenum density means, to be included in our units of measure. The STOE is a holistic emergent model. So the basic units of measure should be the plenum density, such as the magnetic constant and electric constant, the count of hods and hod characteristics, such as its relation to gravity, which, as we saw before, is the count times the gradient of the magnetic field, or its relation to magnetic strength. From the photoelectric effect experiment, the epsilon is proportional to the number of hods in a photon, where you add one more hod, and that then is the slope of Planck's constant. What are emitted photons? Here you see that diagram I showed you before. This is a photon going to the nucleus. Here are photons going between electrons in an orbit, and there may be photons going out from here, which may connect to other atoms. The stable angles, you see these stable angles are produced here, vary such that one extreme would suggest a circle of 8 electrons, the other extreme would suggest a circle of 18 electrons, and these are magic numbers in the periodic table. The model with the spectrophotons being the links between electron leads to geometry and to the larger nucleus magnetic strength, making different radii, length of neutrons to the electron photon. So perhaps the other electrons can also be stable geometric links rather than a surface around a nucleus and rather than in orbits. Friction. In classical, friction is treated as a heat ability to do work, which is a loss, a dissipation of energy, or a force causing dissipation. It seems akin to entropy, yet the Lagrangian and Hamiltonian equations in traditional big and small physics ignore the dissipation of energy. So the issue becomes how to integrate dissipative forces into the STOE. Hods are suggested to be two-dimensional magnets. If friction is a macro effect, the movement of hods is without energy dissipation. I asked on a ResearchGate about the cause of friction in the quantum realm. Emmanuel here answered it was caused by something emitted. Well, in the STOE, this something could be hods. I had already done something like this previously in looking at redshift and the scalar potential model of this pioneer anomaly. Both of them had photons, hods, being emitted from photons as they traveled through space. The photons were considered stripped by means of spallation of hods by the plenum force as the photons travel through space. But where did the photons go? They become part of the background temperature as observed from Earth. And here's a paper where we look at the cosmic microwave background radiation dependent on the source and sink of the galaxies. Wave equation versus heat equation. In the universal equation in the Scalar Theory of Everything, the rho at a given point, which then determines what the forces are on the hods, is dependent on two different types of reaction. One you see here. This then is inversely proportional to R, which is a heat equation derived structure. The other, and here you see the heat equation term from a mass, but this also has a cosine term, which indicates a wave equation. So the problem is, does this wave equation hold, or is it totally a heat equation? Of course, the rho at a given point then determines the force on a given hod. The first two terms, of course, presume the heat equation, and of course that derives the 1 over R relationship. The heat capacity of the medium and a density, usually electric constant and rho, where speeds are like that we saw before, has the advantage that heat processes are irreversible without heat input. This leads then into friction and entropy. Was used to calculate the CMB temperature. That is to say, the heat equation was used to calculate the CMB temperature and the microwave background temperature. The heat equation results in a spherical principle, which is inverse distance of density and exerted on the surface of the hod. This is what Newton called weight. See structure later on. The heat equation is actually very important in physics. It gives the inverse distance squared force and the idea of a point source. That is to say, when R goes to zero and somebody says, well, gee, it's got exponential decay. It has a heat equation. That's why they say particles are point sources, is because they want to have this spherical principle in their ability to represent fields. Yet, the advantage of the heat equation is it allows the plenum to have inertia to support wave action. So that's it, spherical principle versus inertia in the plenum. The third term, that is, say, the mass term, has actually in it the wave equation solution, the cosine term, which suggests the propagation of plenum density has inertia and no dispersive friction in the plenum. See, so it's hods that are dispersed to cause friction. Because the second derivative of respective distance must exist, the Fourier series of a heat equation may be used as an approximation. Is there one evolution equation which has a turning point, such as the area equation? I don't know what it is, but I don't think that there is, where the third term is a solution. Such a situation is also suggested by the magnetic pole repelling experiments, where we looked at inverse distance cubed, and inverse distance squared further away from the magnets. Or the hods may vibrate as they move from high rho to one side to rho on equal to zero on the other side. So they're sitting there vibrating in the plenum, and you have high, low, and it's this kind of high-low switching that then provides the illusion of a wave, the cosine term. But the issue of where does inertia reside remains. So plenum is heat equation, and inertia is a resistance, a force, a hot experience as it tries to move along its axis. But what keeps it moving then? Open question. Entropy. The observed characteristics of the universe is that actions occur wherein some of the energy that was initially present is lost. That's say energy comes in through the source and it's eventually lost out the sink, and in between it declines. It cannot do additional work. The lost energy is called entropy. It has become known as an increase of disorder in isolated systems called spontaneous action. That is to say, there's no external heat or sink inside a so-called system, and the system disorder increases. But what about crystal formation? From disorder, which involves heat release. So here's a system of disordered atoms, molecules, and suddenly they start forming crystals and heat is released from this. This is contrary to the idea of an increase in disorder. So entropy in the STOE is heat release that cannot be recovered, and that covered both situations here, from sources to sinks, heat release from sources to sinks. The energy is Planck's constant times the number of hods, or Boltzmann's constant times the absolute temperature. Therefore, in the STOE, the entities lost are hods, as we saw before. The plenum is related to the amount of plenum that accompanies the captured hods. So here is the STOE universe. We have a source galaxy, a sink galaxy, and these things form galaxy clusters. The source emits hods and plenum, which form hydrogen. Hydrogen travels out from the center of galaxies, forms suns, and some of the suns travel inward by gravity to form nova, and then some parts of the nova continue on and become black holes, which then go back into near the source and are evaporated by the extreme plenum density. Some of the nova elements travel outward as heavier elements. Some go back into the sun. So what travels to the sink is these heavier elements, hydrogen, and of course, light and hods. As this heavy stuff of the hydrogen travels toward the elliptical galaxies, it gains a lot of energy. And so around sink galaxies, you have a cooling flow to cool things down. There are several differences between sources and sink galaxies, and that's here. This then is our view of a galaxy cluster. You then have spiral galaxies all emitting the stuff of the universe, and as the stuff is emitted, some of it forms elliptical galaxies, which then cause the plenum density gradient to direct the stuff of the universe back into elliptical galaxies. So the universe entropy must include a dissipative term, which the standard models do not, and it views that generally the arrow of time is in this direction, but you'll notice this loop here, so this is the arrow of time sometimes, but in the end, the stuff either goes out to sink galaxies, this arrow of time goes back to the source and then back out again. The structure, and this is the structure of subatomic particles. it suggests this building block of the hod, which can be modeled, or we model it as, the analog of a disk magnet. So we use disk magnets in our scale as a fractal or self-similar analog of the subatomic scales. The structures bodies cause the observed behavior. So look for stable geometric structures of disk magnets. Unstable structures produce short lifetimes or antiparticles. A prior paper suggested structure of the photon, neutrino, and electron. That's it. So this is the photon. It's a column of hods, or a column of disk magnets. You'll notice that in the direction it travels, these things are zero-dimensional, so there's no force exerted on a photon traveling in this direction. The same thing is true of a neutrino. There is no force when they travel perpendicular to the paper here because there's no surface area presented. And that is what the toy simulation did using this structure and its interaction with the plenum that produced the toy computer simulation model for the diffraction and interference effects, which is worked in even situations that reject the wave models of light, such as the transport mask Hodge experiment. This is the structure of the electron as we see it, which is a very stable structure. And you know we've outlined the North Pole. So you got one North Pole top to South Pole on the bottom. And of course, the same kind of thing for 4 North Poles. The minimum surface area, you see here's a big surface area and here's no surface area. So the minimum surface area is going to be somewhat in this direction. And the electron is going to be held by its motion to try to be in that direction. This view of the nucleus was suggested by Emmanuel. And you see it's ball magnets forming a proton. This part then would be a proton with electron, which is a neutron. And here's your column of hods. The advantage is the north-south axis is tangent. North-south axis of the proton is tangent to the surface, and that means that the magnetic strength going this way is inverse cube distance, like the strong force, and it allows a column of hods, a photon, to attach magnetically. The STOE accepts holism, emergence, and anthropic principles. That is to say, if something exists, it must be able to exist. So hods become photons with diffraction, which become electrons with the Stern-Gerlach results. Diffraction including the Hodge experiment of transparent masks, which reject all other models that I'm familiar with of light. This seems possible with a rigid flat structure for a magnet, a disk rather than a sphere or a ball magnet. So here you got electrons, photons going to the nucleus, also photons going out to perhaps other structures to provide chemical links, and photons between the electrons, which eventually are emitted when you start emitting spectral lines. So how can photons connect electrons to form what amounts to subatomic particles? Well, you can continue out on either side, here horizontal or perpendicular, with magnets to form long photons, which then connect to other electrons. They can connect in 2 different ways, either straight across or at an angle. So these can be, you can see here, there's 2 magnets here. They can be neutrinos connecting. Here's what the structure would look like for a 2-electron structure with connecting photons. There's two ways to connect, as you can see here. With photons connection, if there are two types of structures with different charge, that means there's 8 types of 3-electron structures with different charges and magnetic reactions to magnetic fields.